Today, we will explore various methods attackers use to exploit weaknesses in cryptographic systems, algorithms, or protocols. Cryptographic attacks are methods used by attackers to exploit weaknesses or vulnerabilities in cryptographic systems, algorithms, or protocols. These attacks aim to compromise the confidentiality, integrity, or authenticity of encrypted data. Think of cryptographic attacks like an enemy trying to break into your secure communications by exploiting weaknesses in your encryption methods. A brute force attack involves trying all possible keys until the correct one is found. Attackers use automated tools to speed up this process. Imagine an enemy trying every possible code combination to unlock a secure door. Eventually, they will find the right code if given enough time. In a known plaintext attack, the attacker has access to both the plaintext and its corresponding ciphertext. This information helps them deduce details about the encryption key or algorithm. Think of it like an enemy having both the original message and the encrypted message. They can use this information to figure out your encryption method. A chosen plaintext attack allows the attacker to select plaintexts and get the corresponding ciphertexts. This helps them gather information about the encryption key or algorithm. Imagine allowing an enemy to send specific messages through your encryption system and seeing the encrypted results. They can use this to learn about your encryption. An adaptive chosen plaintext attack is like a chosen plaintext attack, but the attacker can adapt their choices based on previous results or feedback from the encryption system. Think of it as an enemy adjusting their tactics based on the responses they receive from your defenses. In a chosen ciphertext attack, the attacker selects ciphertexts and obtains the corresponding plaintexts. This can reveal information about the encryption key or algorithm. Imagine an enemy capturing your encrypted messages and somehow decoding them to see the original content. They can learn how to break your encryption. Side-channel attacks exploit physical or implementation-based vulnerabilities, such as timing information, power consumption, electromagnetic emissions, or memory usage, to infer details about the encryption key. Think of an enemy observing how your equipment operates to figure out how to break your encryption, like watching for specific patterns or signals. A collision attack involves finding two different inputs that produce the same hash value in a cryptographic hash function, compromising the integrity and authenticity of the hashing algorithm. Imagine an enemy creating two different orders that look the same to your system, causing confusion and potentially compromising your operations. In a man-in-the-middle attack, the attacker intercepts and modifies communication between two parties, allowing them to eavesdrop, alter messages, or impersonate one of the parties. Think of an enemy intercepting and changing the orders between your command center and troops, leading to miscommunication and compromised operations. A birthday attack exploits the birthday paradox to find collisions in cryptographic hash functions more efficiently than brute force methods. Imagine an enemy using statistical probabilities to quickly find two identical-looking but different orders, confusing your system. A meet-in-the-middle attack involves the attacker finding a match between two halves of a cryptographic operation by encrypting with all possible keys in one direction and decrypting with all possible keys in the other direction, then looking for a match. Think of an enemy trying to match both the entry and exit codes of a secure communication channel by testing all possible combinations from both ends. Understanding these methods helps us better protect our digital base against potential intrusions.